our zero product law lets us take our factors. So once we perform whatever type of factoring we're going to do, it lets us take those factors, okay, which looks like this, like the x plus 7, x minus 2. Those are each a factor. We solve those, and we get where our graph crosses the x-axis, okay? So it says, based on the zero product law, find the solutions to the equation. So if I have x plus 7 and x minus 2 equals 0, here's what our zero product law lets us do. It lets us take them out of the parentheses and set them equal to 0. So I'm taking my x plus 7 out, and I'm setting it equal to 0. Because I want to get x all by itself. How would I get x all by itself here?
-7.
Subtract 7 from both sides. So we would get x equals -7. Okay, I can do the same thing with my x minus 2. Take that x minus 2 out, set it equal to 0. Okay, how would I get x by itself here?
2.
Add 2 to both sides. So we have x equals 2. Okay, this is the only time we're going to use Desmos. You don't need to do it. I just want you to watch me do this, okay? That way we don't all have our stuff out, because you won't need to do this every time. So I'm going to go ahead and go to my Desmos. Let me clear these out. Okay, and my original, what was it, x plus 7?
X minus 2.
X minus 2. Whoopsie. Okay, so if you look at my graph, okay, it crosses at -7 and +2. Is that what we just solved for? Yes. Okay, so right here, we just solved for x equals -7 and x equals 2. Guess what? If I took this, hello, you're interactive. If I took this, okay, and I didn't put that in, what if I put my original in? X squared plus 5x minus 14. Look at that. It's the exact same equation. See if I turn it off and I turn it back on?
But you can do.
Okay, so they're the exact same thing. So that original was factored into the x plus 7, x minus 2. Then we took those out and we said, you know what, we can find those x-intercepts. We just set them equal to 0 and solve them. That's the zero product property. That's all you have to do, okay? But I'm not always going to give you the factored form. Okay, so where we cross the x-axis, what do we normally call those? X-intercepts. We were working with those yesterday. Does anybody know another word? There's a bunch of words for this. Domain is how we write all of the possible x values, but we want specifically the ones that touch the x-axis. Anybody know another word? Roots?
Root canal?
Yes.
I listened to the song.
X-intercepts, roots. Anybody know another word? We call it the roots of the equation, the x-intercepts of the equation.
Honestly.
Space.
Is it the
X.
right?
It's
Race.
I just blanked on the last word, so let me look at my notes. Sometimes it happens to me. I'm like, I know what I'm doing, and then I'm like, oh, crap.
Everybody makes mistakes. Everybody has those days. Everybody knows.
Well, what is it? What's the word I'm looking for?
Hannah Montana.
You guys will find it.
Zeros. They're called the zeros. That's the word I was looking for.
That's what
Zeros.
I said that.
Did you?
Yes.
Okay. Why do you think we call them the zeros?
Because
They're all in the video.
They're when y equals 0. Okay, so another word is 0. So if I say any of those words, solutions, x-intercepts, roots, zeros, they all mean where does your graph cross the x-axis? Okay, that means where does it cross the x-axis? Okay, so here's what we're going to do, okay? We are going to apply our factoring, and then we're going to apply that zero product property, okay? So take a look at number 2. We have 3 terms. What kind of factoring do we have to do with 3 terms? Split the middle, okay? So go ahead and circle STM because we're going to use split the middle here. Okay, so for split the middle, right, I would take my A, which is 1, and my C value. 1 times negative 12 is negative 12. I'm going to do this over here. Okay, and I would find all my factors. 4 and 3, 6 and 2, 12 and 1. Okay, so which set could get me, or could add to positive 4? 2 and 6, but which of them is going to need to be negative? 2, because I can do 6 minus 2 and get positive 4. Tracking?
Yes.
Okay, so let's go ahead and split our middle. So we're taking that 4x, we're splitting it into positive 6 and negative 2x. Okay. If you are retaking, this is what you're going to, right, this is what we did. We did factoring. So this is nice practice for you. Okay. All right, from here we group. We're going to group. Okay, don't lose your signs. Make sure you keep your signs in there. What can I pull out of my first set? Good. So I'll have x plus 6 left. Remember, when we pull something out, okay, so I'm pulling out an x, means I'm dividing each term by x. That's all we're doing there. Okay? What can I pull out or divide by in my second set? A negative 2. So I'm dividing both of these by a negative 2. And I'm left with x plus 6. What is crucial at this step?
Doing that x minus, like, I don't know how to say it.
X minus 2.
What do we have to see here?
The x plus 6 are both the same.
Yes, they're the same. Okay, parentheses are the same. That has to happen. Okay, so whatever is in your parentheses, oops, is one answer. Does anybody remember where we find our other answers? You should know this. Yeah, okay. Those 2 parts that are outside, those come together to form the second part of our answer. We bring those together. Okay, that we're already used to. I know I went kind of slow on that, just for kind of refresh for factoring. Okay, now here is where we apply our zero product property. Okay, I take my x plus 6 out, and I set it equal to 0. I take my x minus 2 out, and I set it equal to 0. So this is the part that's new. This is our solving. This is the part where we solve. Okay, to solve this, I would subtract 6 from both sides. So I have x equals negative 6. Okay, come on in. I have x equals negative 6. With my x minus 2, I put here. What am I going to add?
2.
Add 2 to both sides. And we have x equals 2. Okay, what are those? What is x minus, or x equals negative 6 and x equals 2? Those are our x-intercepts, where we cross the x-axis. Is it coming together? Okay, so if I was to graph this, I would plot negative 6 over here, positive 2 there, okay, and I would have my parabola.
What is it positive 1?
No, because the bump.
What would be
Never
positive?
mind, never mind.
Yes? Making sense? Okay. So this is one way that we use factoring. Pretty cool. Ready for the next one?
Yes.
Okay, what type of factoring?
GCF.
GCF. Okay? We only have 2 terms. So when we only have 2 terms, automatically it's not going to be split the middle. It's going to be either GCF or DOF. Okay, and you have to decide which one. What can I pull out of each term? 2x. Let's redo this. So if I pull a 2x out, or I divide by 2x, what do I have left?
X minus 7.
Beautiful. Now, you're probably looking at this like, wait a second. We don't have 2 parentheses here.
Fine.
That's okay. anytime you have an x, okay, here's our zero product property. Anytime you have an x that is outside and there's nothing added or subtracted to it, guess what? We can still set that equal to 0, okay? But only, hear me when I say this, only if we have an x. If it was just 2, would it matter? Does 2 equal 0? No. So only if we have an x out there, okay? And then again, we could do our x minus 7 equals 0.
Could never mind.
You good? Okay. How are we gonna solve for x right here? Divide by 2.
But wouldn't that be 1?
What's 0 divided by 2? 0. Okay. Here, add my 7. You get x equals 7. So our x-intercepts should be 0 and 7. Okay. Now I'm going to prove that to you by just doing Desmos. Don't get Desmos. I'm going to do it up here. Okay. I just want you to see this one because it's a little bit different with that x equals 0. Okay. What was it? 2x squared. Is that what it was, friends?
Yes.
Okay, so if you look up here, take a look. Okay, we have an x-intercept at 0 and an x-intercept at 7. Okay, so when you are working on your quiz or your test or whatever you're doing in this unit, check it with Desmos. Make sure you got those x-intercepts right, okay? Because you're going to be able to bring a computer for your quizzes and your tests in this unit, and you can use Desmos to help you. Now, I have to see the work for what you do, but it's a good way to check yourself, make sure you're getting the right x-intercepts, okay? We good? All right, let's keep moving. All right, number 4.
Square.
3. That's right. Okay, so what type of factoring do we have? Difference of squares. Okay, difference of squares. So when we do difference of squares, this is where we take our square roots. Okay. Let me ask you though, how did you know it was difference of squares and not GCF? Raise your hand. Raise your hand. Tell me. How did you know?
Because, well, they're both perfect squares and that's really subtraction.
Yep, both perfect squares, because there's technically a 1 in front of the x squared. There's no GCF, right? So that's obvious. And there was subtraction there, okay? So, when we take the square root, I need you to listen up. When we take the square root of x squared, we get x. Square root of 25, 5, okay? One of them will get a plus sign, one of them will get a negative sign. Okay, so that's the factoring. Now our new part, we're going to do our zero product property. Okay, here I subtract 5. Here I add 5. Okay, if we put it into Desmos, it would cross that x-axis at -5 and positive. So, yeah, because you have to solve them. Like they're going to be different. Does that make sense? Like this one, this x minus 5 becomes positive 5. Oh, here. Oh. Okay, number 5. What type of factoring? Split the middle. Okay, I need you to focus on this one, please. Okay? Something weird's going to happen here, so I need you to focus. Okay? 2 times 12 is 24. That's our first step of split the middle. Okay, give me the factors of 24.
6, 4, 3, 12, and 2.
Okay, so taking a look at our combinations, is there any way we can add to 1? No. What would we usually say if we were factoring here? Prime. Do you remember yesterday when we were graphing and sometimes our parabolas cross twice? Sometimes they cross the x-axis once, but then sometimes they didn't. Okay? If it doesn't cross at all, you can't factor it because there's no x-intercepts. Okay? So in this case, you're just going to say prime, okay, and you're going to say doesn't cross.
Don't cross you.
Okay, so for right here, for these, we don't have any doesn't cross. Okay? does not drop.
That's how you use it. Oh my god.
Okay, I think if you never remember.
I like the purple.
Yes, go ahead and flip it over. Those are practice, okay? And here's what I need you to do. I really need you to work on these today, okay? You got to get these worked on because I need to know if I need to help you before we may not be here tomorrow, okay? So work on this now. Make sure you're solid, okay? If you're not, ask me questions, okay? While you're working, I'm going to pass out the worksheet that we're supposed to do tomorrow, just in the off chance that we're not here, okay? You do not need to do this for homework. You do not need to do this for homework tonight, okay? If tomorrow we're off, just make sure it's done before Thursday, okay? Oh, you can just put this in your folder. You don't need to do this now. I want you to work on the practice that you're working on. Okay, put the one I'm passing out now just in your folder. Do I want like that?
I was gonna say one of the that was very dumb.
Visible light too.
No.
Do you know what?
How'd that happen?
There
you go, Colin.
Hey, there's the hippo.
There's a hippo in it?
Hold on.
All right, great. Make sure we're working, please. Make sure we're working. Okay, my key is up here if you want to see my answer key.